Hey guys, welcome to session 7 of METC 107. In this video, we're going to put everything together for the first time and make our first finished product. We're going to make a drawing page. So we've been working for a number of sessions now on trying to put all this stuff together. We talked about traditional technical drawing. We've talked about a lot of parametric sketching, some 3D creation tools. We talked about in session 6 the rules for dimensioning a drawing and creating drawings. And now finally we're going to take it and put it all together, and we're going to make our first completed, finished drawing page. Before we get to that, I want to talk about the midterm exam, which is going to be your assignment really for session 8. So I want to talk about that just so you kind of know what's coming up. You can mentally prepare for it. It's nothing to stress about, but I do want you to kind of know about it because it's worth a lot of points. And I want to make sure that you know it's coming up and what to expect and how it's going to work ahead of time. So let's talk about that really quick, and then we'll shift gears and get back to creating drawings in Inventor IDW files. So just a little bit of a preview here looking ahead. And again, I'm teaching this originally in the summer 2020 semester. So if you're taking this in the fall or in the spring and you're seeing this video, these dates will be different, but the procedure is going to be exactly the same. So you guys will see this activate in session 8. At the normal date for session 8. You're going to have a week to do the entire exam, so the amount of time is still the same as it would be for a normal session. So this is going to be an open book exam, and I make them open book just because you guys are doing this at home. That way I don't have to try and drag you into a testing center, or you don't have to download some kind of test proctoring software. So this is open book. You're able to do it on your own at home with the resources that I've given you in Ivy Learn so far. So if you guys want to go back and watch my videos in the middle of the exam, you're more than welcome to do that. If you forget how to do something, go back and look it up. If you need to go back and look at one of your previous lab assignments, or a PowerPoint that I gave you, or a reference PDF that I showed you, or you want to go back and look in the textbook that I provided at the very top in Ivy Learn, all that stuff is fair game, okay? And the reason I do that is, to me, if you're doing CAD in a work setting, you're going to have every resource available to you. So you're never going to have, hopefully, an employer that says, you know, don't use the resources that are available to you. Don't use the internet. Please don't go search out the answers to your problems. We want you to sit and struggle at work and waste our time and waste our money and make our projects late. No one's ever going to tell you that. So the way that a real work setting works is, if you have a problem, it's your job to figure it out. And so that's kind of how I work my tests. I'm going to give you some basic exam style questions. So true, false, matching, fill in the blank, stuff like that. That's going to be the first 10 questions on the test. I'll just show you because it's open book, so there's no reason I shouldn't go ahead and show you. But and then the last part of the test is what I call the practical part of the test. Okay, meaning that you're going to open up the software, actually do something, take your file, and then upload your finished file into the test. Kind of like when you guys upload your homework. Okay, so let's just look at this really quickly. That way in session 8, you'll kind of know what's going on. So you do have 230 minutes to finish this, which is just a hair under 4 hours. I do this because of the time limit that we normally have in a regular face-to-face class. My students get about 2 hours or really 3 hours and 50 minutes usually to complete these exams. So in the interest of fairness and to make sure the GPA is fair across our program, I'm going to give you guys the same amount of time, but you're going to have all week to do it. So you can choose during the week whenever you want to complete it, as long as you complete it within that 1 week time frame. And then you have that whole 4 hour time frame nearly to complete the test. So once you get in there, make sure you have time where you can sit down and work on this and finish it. You don't want to get 10 minutes into it and then realize, oh, I got to go do this or that, and I can't finish the test. So make sure you have some uninterrupted time where you can sit down and work on this. Now, I don't anticipate this is going to take you the whole 4 hours. Honestly, I've kind of designed this test so it should take you maybe a little over an hour. So I kind of look at this as it's really a 1 hour test, or maybe hour and a half, and I gave you 4 hours to do it. So you should have lots and lots of extra time. I don't see the time limit being an issue. So if you just want to know that ahead of time, you should be able to do it within an hour or hour and a half probably. So So once you get in here, if we hit the preview button here, what you're going to do basically is answer all the questions within the test in session 8. And, like I said, the first 10 questions are just textbook type questions, things that come from the lecture, things that come from the PowerPoints, things we've done together. You'll probably see some of the figures even look familiar. There's some short answer questions you can go through, just type in your answers directly within the test. Then when you get to question 11, these are the questions where you guys will actually do something and then turn it in. So for instance here, this is just a 3D modeling question. So you're just going to take this in Inventor, you're going to model the part in inches, and then give me your part file, your IPT file. You don't have to create this drawing page, you're just making the 3D model. Same thing on number 12, this one's just metric instead of inches. So you're going to create the part file that looks like that, and then you'll hit right here and upload your file when you're done. Same thing on this question up here. So you can upload your IPT file directly within the test. And then on this question, you're going to take the model that I've given you. So I've given you the part file already. It's in the Module 8 folder. So any files I need to give you will be here. If I expand this out, so like here's the file for question 13. So you can click on that and download it. But on this one, I'm giving you the 3D model and I want you to make the drawing page, which we're going to learn how to do today. So you don't know how to do that yet, but I'm about to show you. And you'll make the drawing page. Then questions 14 and 15, these you are going to download and do on paper and then upload your PDF. So these are intended to be done with pencil and paper. So I have not yet, but I will link these inside of session 8 where you guys can download these. So there will be a question 14 and a question 15, just a PDF. You guys will download those and they will look exactly like this. You'll download them, print them out, and then, or you can do it electronically too. If you have some way of drawing on screen, you can do that. Or if you want to do it like in a photo editing program, you're more than welcome to do that. The easiest way probably would just be to print it out, do it on paper, and then scan it in or take a photo. But if you want to do it completely electronically in some kind of editing software, you're welcome to do that also. But for instance, on this question, you're just going to measure the drawing and list the dimensions on it, just like we did for the session 6 homework. You're just going to take your ruler, measure it, and then list the dimensions. Okay, so you're going to use those rules we talked about for dimensioning. And then the very last question, this is sort of a multi-view orthographic drawing question. Same deal, you'll take the drawing that I've given you already that looks just like this, print it out, or on your computer, you will draw the missing view over here. You'll notice the right side view is missing. You have the isometric, the front and the top view. So you'll draw the missing view here and then either scan it back in, take a photo, and upload your finished version right here. Okay, so everything can be done directly within the test and within the time frame, hopefully. So I'll remind you of all this in another video when I turn on the test in session 8. But I wanted you to kind of know what's going to happen in session 8, how this is going to work, so you can kind of not worry about it too much, hopefully, as you see this midterm exam coming up, like, oh my gosh, how's this going to work? Open book, low stress, should take you about an hour, hour and a half, but you have 4 hours if needed. Everything's done directly in here. Make sure your Inventor's working. Make sure you have some time to work on this where you're uninterrupted, no one's going to bother you. And then make sure you have a way to either edit these virtually, these last two questions, or you have a printer where you can print them out. Okay, and you can print these out ahead of time because I'm going to link them in here. So you can actually print question 14 and 15 without opening the exam, because once you open the exam, that timer is going to start. So if you need to, you can print question 14 and 15 out ahead of time and have them ready to go when you start the test. So just a heads up on that. Okay, so that's all I want to say about the midterm exam right now, and I will make a reminder video and put it in session 8 also, and kind of walk through the test one final time when I activate it on session 8. So that's all I'll say about the midterm exam for right now. So let's go back, let's talk about session 7. We got a lot of stuff to talk about here. None of it's a high level of difficulty, but we got a lot of stuff I want to talk about, so we're going to go through it at a little bit quicker pace than normal probably. I'm missing a file in here that I thought I uploaded, hang on. Unless I put it in the wrong folder. No, there it is. Okay. So we're going to talk about making drawing pages. And so we're working in session 7. And this is our chance to put everything together. So the first thing I want to show you before we do anything else is I've made a template for you guys to use for all of your drawings the whole semester that has the IVTech logo and has some different things on there that we can use. And I want to show you just really quickly why I made this template. So in your Inventor software, you have some standard templates for your IDW files, your drawing files. And if we look at English, for instance, on inches, you'll see right here, .idw. IDW is the preferred file format for Inventor for drawings. Please, please, please do not use this DWG. This is an old school like AutoCAD format. I don't know why they have it in here as an option because it's really not the correct one. So when you make your drawing pages in Inventor, you always want to use an IDW file. Don't use the DWG. Okay, I wish they'd take that out, but it's always in there, so we got to deal with it. So I'm going to make a template to give to you guys, which I actually already have. I'm going to show you how to import it. But it's going to replace the standard templates in Inventor, and there's a reason I don't like them. So in Inventor, they have this ANSI template, and I think there's also maybe an ASME one. But if you use this on regular computer size, like 8.5 by 11 paper, the problem with this is if I use a small sheet size, which would be an A size, or 8.5 by 11, the title block is giant, that it takes up most of your page space down here, and so you have very little room left for your orthographic views and your dimensions. And most of these boxes aren't really necessary in this title block. So I went ahead and made an IVTech one that I think fits our needs a little bit better, and it's also a little bit smaller. It kind of fits down here, and it gives us more usable page space on an 8.5 by 11 A size sheet of paper. So what I want to show you how to do very first is how to import in those IVTech templates that we can use instead of the standard Inventor one that you see right here. So let's go through it. So what we're going to do is we're going to go to IVLearn. We're going to go up to nearly the very top where it says Autodesk Inventor Drawing Templates. You should have this activated now. I've got it set on a timer where it should turn on automatically. And I did do this in a separate video if you ever need to come back and see it again, but I'm going to show you right now how to do it. So if you click on these two files, we want to first of all download these, okay? So I'm going to click on this one. This is the template for inches that I made. You're just going to click the link and you'll see that it downloads down here. They're not very big, they're like 2 or 3 megabytes. So I'm going to go back now, grab the other one that's metric for millimeters. So the other one right here, IVTech Inventor Template millimeters.idw. So I'll click on that guy. Click on the link again to download it. And let that finish downloading. Looks like I accidentally downloaded it too many times. That's okay. We'll sort it out later here. So the trick to doing this is when we go to the new button up here, either File New or you hit the new blank piece of paper up here, whenever you use one of these templates in Inventor, we want to add a template to this menu, really 2 of them. We want to add the metric and inch drawing templates for IVTech. So the trick to this is, well, how do we do that? How do we make our files that we want to put in here magically appear when we go to new, because they're not in there? The trick is this file path up here at the top, that you're going to go to a very specific folder on your computer, and I'm going to show you how to navigate to it. We're going to go to a very specific location in your file manager and take those 2 files we just downloaded and paste them in, which will cause them to show up right here. Okay, so let's do that. So I'm going to go to my downloads folder in my file manager here. So I'm going to go to downloads and I'm going to find those 2 files that I just downloaded. If you have a bunch of downloads in here like me, you can hit the date modified button a couple times and the newest ones will pop up to the top. So I'm going to grab these 2 actually right here, and I'm just going to right click and copy them. Okay, so those 2 files are now copied to my clipboard. So I'm going to go to the correct location now and paste those things back in, which causes them to pop up in the IVTech menu, or in the new drawing menu. So let's go to C, Users, Public Documents, Autodesk, Inventor. You can see I've had Inventor on my computer a number of times, but I'm using 2021 right now, so I'm going to go to Inventor 2021. And then finally, we're going to go to the templates folder. Okay, now when we get in here, this is where all the templates on your computer are saved for Inventor. I'm going to go into this en-us folder, and you can see these are all the templates that we recognize inside of Inventor when we go to that new menu. So what I'm going to do, instead of just pasting them in here, is I'm going to right click and make a new folder, and I'm just going to call it IVTech. That way I know that's where my IVTech templates are saved at. So if I double click that IVTech folder, now I can right click and paste, and my two IVTech templates are in the correct location now. So what that does, if I go back to Inventor now and I go to new, you're going to see that folder populate into your list, and now I have two IVTech templates I can use. So that's the trick to getting these to show up on any computer. You basically download them and then paste them in that very specific location within that template folder. And it's tricky to get to, so you may need to rewind the video and watch that file path again when I went through it. It's a lot of clicks. It's not hard, it's just trying to get to the right spot. Okay. So let's go ahead and jump into a template. Okay, now a couple other things that you're going to see me using that you probably will want to download is, if you remember last week, we went through and I kind of set up my camera over off to the side, and we actually went through and dimensioned two drawings by hand with pencil and paper and a ruler. I went ahead and actually modeled those two parts just so we can kind of use them for reference. You can see them here. So they probably look familiar. So 3D model, that's what these two pieces look like. So here's the first one we did, and then here's the second one we did. These probably look familiar to you. So we're going to actually take these and try and recreate another drawing of them in Inventor. So kind of like we did last time. So if you remember in Module 6, we had those two drawings with all the dimensions on there that we went through and measured the different views. So just for reference here, I'm going to pull these up. My poor computer is running slow today. I think I've got them in my downloads actually already. Yes, I do. So let's open those up. So these two guys here probably look familiar. So this one and this one. Okay. So we're going to look at finishing these now, but doing it in the software instead of with a pencil. So a couple things we need to know, kind of looking through here. When you make your drawing files, again, make sure you're using IDW always, but at the very beginning, it's important that you pick the correct template. So when you go into new, obviously we made two templates, right? We just imported those in. It's important that you pick the correct one from the beginning. If you pick the wrong template, it's very difficult to switch all the dimensions from one measurement system to another. So a lot of times in class, students will ask me, hey, I chose the wrong drawing template and my drawing's actually all in inches and I need to switch it to millimeters. Where can I go to do that? And the short answer is you can't really, because there's so many settings because of the ASME or the ANSI standards or the ISO standards. These two templates are programmed in for different standards. Okay, remember, one is the American Society of Mechanical Engineers, the other one is the International Standards Organization. So there's a lot that's different between the two templates really that people don't notice, but it's not an easy fix. So the easiest thing to do if you choose the wrong template is just to start over, honestly. So when you pick a new template for a drawing, make sure you're always choosing the correct one, whether it's inches or millimeters, and you'll save yourself a lot of grief. Okay. So we did both of our drawings in metric last week, so I'm going to start with the IVTech template in millimeters and click on that. Okay. So when you do that, this box pops up. This is what's going to fill out your title block down in the corner of the drawing. It's just asking you some questions. You might know most of them, but there are probably a few things you'll have to come back later and fill out. So use all caps on your drawings always. This seems weird to people now because of social media and texting. People look at all caps as screaming or impolite. Remember that all this technical drawing stuff predates, current technology. So back in the technical drawing hand drafting days, everything was done in caps because it was easier for the drafters to mimic each other's handwriting styles. All caps text is actually harder to read, but it looks better on a drawing, and it's easier to make the letters consistently the same shape between people. So what that did is it let companies standardize their writing styles, and all the different drafters could write in the same style, and the drawings were consistent and repeatable then. So it's kind of like an old school, leftover thing, but technical drawings are still all caps. It's just like a weird thing that nobody's ever really changed. So when you do drawings in Inventor or any other CAD software, turn your caps lock on and just leave it on. So, you know, things in here, enter your drawing title. So let's call this practice drawing 1. Author name, this would be whoever's making the drawing, so J. Hamilton. If you have a really long name, like your last name's really long, or it's hyphenated maybe, you can also do your initials. So sometimes I will do J-E-H, which are my initials. If your name is long enough where it doesn't fit in the title block, you can also abbreviate it. That's okay. Okay, I know mine does, so I'm going to put J. Hamilton. Enter the date. So whatever the current date is, I'm doing this on July 27th, 2020. The measurement system, so I'm working in millimeters, so I'm just going to put mm. The drawing scale I don't know yet because I don't know how big I need to make this to fit it on the page, so I'll come back to that later. The course number, METC 107, and then the course name, you'll probably need to abbreviate this, mechanical design and documentation. Okay, so we filled in most of that, so I'm going to hit OK. It's going to do some thinking. It might yell at you with an error message about a style conflict. This is like a little nitpicky setting inside of Inventor. Just hit OK. If you don't want to see this every time, you can also go to prompts and say, don't show this message again ever, which I typically do because it gets kind of annoying. And here's our drawing template. Okay, so we've got a nice border ready to go. We got our title block in there. You can see all the things we typed in have populated themselves into the title block. So the only one we need to remember to come back and fill out is our drawing scale right here. Okay. So I want to show you a couple of things just in general about setting up a drawing before we start doing a whole lot of crazy stuff. Just general things you're going to want to know. So first off, this is the biggest one. This is probably one of my biggest annoyances in Inventor as a professor, is adding sheets to your drawing. So this is probably the #1 most annoying mistake that I see people make, and I'm going to tell you early on so we can hopefully avoid it. When people make drawings in Inventor, if they need more than one page, a lot of times what people do is they make a separate file, like a separate IDW file for each individual page. And it's because they don't know how to add pages to their drawings. Okay, so what they'll do is they'll make one drawing page. You can see down here it says sheet 1 of 1. What they'll do then is they'll go back to new, make another brand new drawing file and save it. And what you've done now is every drawing has its own individual file and its own file path and its own file name. And it's very complicated, and it makes it hard when you need to edit pages to go back and forth from one to the other. So if you need more than one page in a project, don't make a brand new file for each page. Please don't do it. I'm begging you. Okay, here's what you do. It's really easy. They even made it easier because they put a new button up here that says new sheet. That didn't used to be there. So the old school way you do this is you click at the top where it's, you know, whatever your file name is, you right click at the top and go to new sheet, and it'll ask you all the questions again. You can fill them out, and now I have another page over here. Okay. They also added this nice button up here, which is new, and I like this a lot. This was a good addition to the software. You can hit that button, it does the same thing, and people know it's up there. It was too hard to find that before. It was buried over here in your browser, and unless you knew to right click, you wouldn't find it. Okay. So if you need multiple pages in a project, like maybe you've got 6 parts that go together into some kind of assembly and you want all those 6 pieces together, don't make 6 separate files. Make one IDW file and then just hit the new sheet button 5 more times to get your total of 6 pages. Okay. So watch out for that. There are times where you'll make different IDWs, obviously, if they're 2 completely separate projects, but for one project, it should all be one IDW file. Now, with that being said, there's one other thing we need to watch out for from a file management cleanliness standpoint. When you make a project, you're going to link 2 files together now, and we're starting to get into a little bit more of the file management that relates to parametric modeling. So when I make this dimension practice #1, I want to make sure that my part file and my drawing file, my IPT and my IDW, are always together in the same file folder. They're going to live together now in the same file folder, and they need to stay in the same location. You also need to be very careful about renaming files. This is where people start to have issues if they have bad file management, and I want to show you what I mean. So I'm going to break this on purpose so you can see what I'm talking about. Let me move my part files here so I can do this correctly. And then I'm going to break it on purpose to show you what's wrong with this. So if I go to my downloads folder, I'm going to take my two files here. So Dimension Practice 1, let's copy and paste him to my desktop. I've got Dimension Practice 2 in there. I'm going to move these into my METC 107 folder. Let's make a Session 7 folder. I'm going to take these guys and just drag them into that folder. Okay, so here's my good file management, right? I'm working on Session 7 stuff. Here are my practice files. I've got them in there. This is where I would want to save my IDW file, okay? So let's go in here. Let me delete these extra sheets. I don't really need these, so I'm just going to right-click and delete those. Do I want to delete the selected sheets? Yes. Okay, so let's say I've got this. I'm just going to throw a base view on here just so I can make a point. And Inventor is going to ask me, okay, well, what are you making a drawing of? So I can navigate to my Session 7 folder and say, hey, I want to make a drawing of this file. And now I can set up some drawing views. So let's say this is my drawing. This is totally incorrect, but just for reference. Say that's my drawing. I did a really good job setting it up. I want to show you the file management problems with this. So if I save this, I want to save this with a name that makes sense, and I want to put it in the same folder as my part file. So I'm going to go into that folder, Session 7, and I'm just going to call this Dimension Practice number 1. And this is going to be the IDW file, and I like to give my drawing files the same name as the part file. That way they're different file extensions, but they have the same name, and I know they go together. So I'm going to hit save here. Hit OK. Now if I go to my file folder, notice I have two drawings now that go together. I have the part file and the drawing file, and they have the same name, but they have different file extensions. Okay, one's a part and the other one's a drawing. Now, the trick on this is a lot of times people have bad file management where they give things bad names at the beginning, like they call it Part 1 or Part 8. And they decide to come back later in the drawing phase to rename these things once they get so confusing that they get frustrated. Here's the issue. Think of this, I think of it sort of like mail, that if you're going to move or change your name, you know, like maybe you're going to move houses or you get married and your last name changes, you have to let the post office know that so they know where to send your mail. There's kind of two versions of that from the Inventor side of things. So let me show you the change of address thing first. If you move and you don't tell the post office that you moved, you're not going to get your mail. So let me close my drawing here. I'm going to take my part file and I'm going to move it. Okay, I'm just going to drag it. Instead of in this folder, I'm going to drag it to my desktop. Okay. Same file, I didn't do anything to the file other than I moved it. Now when I go back to open my drawing, you're going to see that Inventor is angry. And you get this error message and it says resolve link. And down here, you know, it says unresolved reference, i.e. not found in project, Dimension Practice number 1. So the issue is that when I created those two files, the drawing file and the part file, I had them together in the same folder and both of the files knew where the other one was at. Okay, so there's a link between those two files that needs to remain. It can't be unbroken, or it can't be broken. So when I take that Dimension Practice number 1 part file and I drag it to my desktop, now Inventor is mad and it says, hey, you made this drawing and there was a part file and now you took it away. Like, what's going on? Where's the file? So it's sort of like you moved and you didn't tell the post office what your new address was. Okay, so to avoid this, give your files names that make sense at the beginning. Don't change them in the middle of a project. Like, give it a name from the very beginning that makes sense and put it in the folder where you want it to be from the very beginning. When we get into more complicated models, this will get to the point where if you move files around and change all their names, it gets complicated enough where you can't figure out what's going on after a while, and it's almost impossible to fix. Especially if you've got 15 or 20 parts and you rename them all, trying to figure out which was the old name and what's the new name and how do I patch up the reference that I've broken, it gets really confusing. So give them a name that makes sense and put them in a folder that makes sense at the beginning. You'll be really glad later on. So there's two ways I can fix this now. The sloppy way is I can tell Inventor, well, I actually moved it to here. It's not there anymore. And Inventor's mad and it says, whoa, whoa, whoa. These aren't even in the same folder. Like, what are you doing? This isn't the active project folder. And you can ignore it and say, oh, whatever, it's right here. That's the sloppy way of fixing it, okay? The good way, like the correct way of fixing it, is to take that file and put it back where it goes so Inventor can find it. So I can take this and copy it or move it. You know, let's just drag it back in. I can take it and drag it back into that folder and say, no, you don't live here. You actually live inside this folder. Now they're back together again. So if I open up that drawing file, Inventor's happy, no error messages. Okay, so that's the change of address thing. You can also have a change of name. So if I go back and change the name of my part file, okay, it's the same exact model. If I open it up, you know, nothing else has been changed here. Right? It's the same part file. But now when I go to open my Inventor drawing, it's mad and it says, well, the file that I used to make this drawing is gone now. What happened to it? You can tell Inventor, well, I changed the name of it, or you can put the name back the way that it was. So I could rename this back to its correct name and then open up the drawing page, and Inventor's happy. Okay, so file location and file name are two big things when we go on here that's going to be very important. Save all your part files and drawing files and assembly files for a project inside of a folder together. They all need to stay together. Give them names that make sense at the beginning that you like, and please don't move them in the middle of a project. You will run up against all kinds of file referencing issues and file location issues that will drive you insane. So take that as some sage advice from me. I've seen it happen to enough people early on. I'm going to help you try and avoid it. So why does this file referencing matter? So let's look at what is the benefit of struggling with these file names and file locations, and why should we care? So here's the huge benefit. And you're going to like this based on, you know, some of the few orthographic pencil sketches that we did. Let's set up a drawing view here. So let's actually set up our practice drawing number 1. Let me delete all this stuff. Okay, the way I like to set up a drawing is I like to have my part model open in the background, and then I like to actually be working on my IDW. So I'm actually going to go ahead and open up both files at the same time. I've already got my drawing page set up. We're working in millimeters. I'm going to open up my practice file in the background. So here's my IPT. I've got my drawing file, and you can see on the tabs down here at the bottom, I can jump back and forth between them. So let's go to our drawing page and let's set up a 3-view multi-view drawing with an isometric view up in the corner. Standard drawing setup, right? So I'm going to go to base, and you can see since I have my part file open in the background, Inventor goes ahead and makes an assumption and it says, oh, well, hey, I see you're working on this part file in the back. That's probably what you're doing for the drawing too, right? And so it automatically populates the file path in here for the model that you have open in the background, which is nice. So now I can just tell Inventor what I want to use for my front view, what scale I want to use, and how I want to set up the drawing views, and then I can click and place them. So I'm going to try and do this at a 1:1 scale. Let's see if we can fit it. I think that'll work. So I'm going to grab this kind of 4-way arrow over here, and I can move my views around to there. I can move over here, and you can see this is showing me what extra drawing views are going to be created. So I'm going to go over here to the right and click and say I want to have that drawing view. And I can go straight up and project up and say, give me that drawing view also. Then I also want the isometric. I'm going to come up here in the corner. You're going to see this is way too big, but we're going to adjust it. So I'm going to click up here in the corner now, and it's going to create the isometric view. So I can hit OK now, and there are my drawing views all created. So a couple issues here we need to fix. First off, this is way too big. It doesn't fit on the drawing page. So I'm going to go to the border on that isometric view and just do a quick double click. And now that lets me edit this view. So what I want to do is shrink down the isometric view. So I'm going to show it at half scale and hit OK. And we're good to go. So your orthographic views here, these 3 always need to be the same scale. They all need to match, and Inventor will make that happen because these 2 views are controlled by this one. So you'll see if I change this one, my front view is sort of like the master view. If I change it, the other 2 follow automatically because they're controlled by this one. So by the rules of orthographic drawing, the top and right view always need to be the same scale as the front view. So anything I do to this one, the other ones follow along. Now you can also change the style of the views. This is something I like to do just for the isometric view typically, but if I go on my front view, these two buttons here choose whether you have hidden lines or whether you don't. So this is just visible lines, this one is visible and hidden. So you'll see if I switch this and hit OK, it takes my hidden lines off the drawing. Really, I don't know why you'd want to do that too much, because you have to have them on there. So for any of your orthographic views, you always want to have those hidden lines turned on. But you can turn them off for some reason if you would need to. The isometric view up in the corner, I like to set those to be shaded, which just makes them look a little more realistic. If they have a material type, they'll show the material type. And you can do that by hitting the shaded button and hitting OK. And it just gives it a little bit more realistic appearance. Then I just take it and kind of tuck it out of the way up in the corner. Don't show hidden lines on isometric drawings. By technical drafting rules and technical drawing rules, that's really considered to be incorrect. You don't want to show hidden lines on isometrics like that. It's considered bad practice, and most people would consider it to be an error on your drawing. So for your isometric view, you definitely want to have just visible lines, no hidden. And then I like to shade them. You can choose whatever you want to do, but I think it looks nice when they're shaded on the drawing. So there's the basic setup for our drawing. Now, here's the huge advantage of parametric modeling and why we try to maintain that link between the part file and the drawing file, and we're careful with our file names and our file locations. Here's the advantage. You have a continuous link between these. So if I make any changes to the part file, like I decide I'm going to put another hole in this thing, like maybe I'm going to put like a semicircle cutout in the top of this part that goes all the way through. And let's say I do that, and then maybe I'm going to fillet this edge and this one, and then maybe this edge down here. And I'm just trying to make this part more complicated. So let's say that I'm also going to put on this face, let's put a slot right here that goes through the whole part. Like that. Okay, so this part's getting pretty complicated now, right? But we took what was fairly simple, and just with a few quick changes, we've made the drawing a lot more complicated. So trying to draw this now with a pencil in an orthographic setup is going to be tricky. But because there's a continuous link between my part file and my drawing file, if I save this and I go back to my drawing file, it automatically updates itself. Okay, this is the huge benefit, and this is really why parametric modeling was originally created. People in AutoCAD were tired of spending their whole day chasing down changes in drawing files, that every time a project got changed or redesigned, it was almost like they had to redo the entire project from scratch. And when you go through and you change these line by line, curve by curve in AutoCAD, and you're actually manually drawing all the shapes, things get missed and mistakes get made. And because of that, your changes became very time consuming, and they were not very accurate a lot of times. The benefit of having a computer draw these views from a 3D model is that they're always correct. The computer will never forget to fix a line, because computers are great at repetitive, monotonous work. So if we can make the 3D model look like how we want it to, let the computer draw the orthographic views for you. And that's the huge advantage, and really one of the main reasons why parametric solid modeling was originally created, was to fix this annoying problem of having to go back and manually fix drawings of multi-view objects. Okay? The computer will fix them now. So if I go back and continue to add more and more stuff to this, you know, the computer doesn't care. It doesn't really run out of memory or run out of capability like a person does. I can make this part quite complicated. And I can increase the number of faces and edges and intersections that are in this part. And the computer really, for the most part, it just doesn't care. Now, if you get into something that's really, really nasty with, you know, millions and millions of edges in it, it might run out of memory. But, you know, now look at, we're getting something really nasty here where we've got all these different curves that are intersecting and they're all going at different slopes. Trying to draw that with a pencil is just about impossible, right? But if I save this and jump over to my drawing page, your computer just doesn't care, right? It says like, okay, well, here's what the views look like. because it has the ability to crunch all the numbers and the geometry and figure out all the intersection points and where the curves lie at based on their depth perceptions. So this is the reason parametric modeling was really created. And it gets just even better when you start looking at assemblies of parts and you have, 30 or 40 parts put together into an assembly. The capabilities just get even more and more powerful. So maintaining that link between your part and your drawing is incredibly important, and this is why, is it's ultimately to save you time and work. Okay, so let's rewind a little bit. I'm going to go back and undo what I did here. This isn't actually the part we want to dimension. So just do a bunch of Control-Z's, save this, go back, and life's good, right? Very little work, really no work required by me. So what other things do we need to talk about? Well, let's look at if we want to finish up this drawing. It's missing center lines and center marks. This is another kind of a pet peeve of mine, or things that people forget. Here's how you put them in there. If you go to the Annotate tab, you can go up to this little bullseye right here. This is for center marking holes. This is anywhere you see the object is round. Don't center mark fillets though. That's it's kind of like a faux pas. So hit the bullseye, choose your round objects. They're center marked, you're good to go. Now we want to do them in the side also, but these are going to get center lines instead of center marks. So for these, there's two ways you can do them. One way I like to use is this one. This is called center line bisector. And what you can do is choose the sides of the hole, and then it'll put a center line right between them, right in the middle. So that works really good. Now for this side, it doesn't, because you can see I have two different heights here. So I could do it that way, but if I try to do this one on the bottom, you can see it's not going to put the center line far enough, and I end up with that. So sometimes you might want to use the actual center line tool where you can just draw it. So you choose endpoints like these green center marks, and I can just draw it in there. And then when I draw it, after I get it where I want it, I can right click and go to create and put a center line in that way. So you can manually draw them. You can use the center line bisector tool. You can also do automated center lines. This is kind of it's a nice tool when it works. So if I hit that, I can choose a view. And this kind of works off the hole tool. But if you want to go through and mess with it, it's kind of a lot of clicks. So it does work, but you got to tell it what kind of stuff you want to use. I would use this for a much more complicated view. So say like, I want to do all the hole features. But you can see then I extruded these instead of using the hole tool, so it's not going to work. So it's kind of picky. You have to think about this in the model menu really, and how this is going to work. So I typically just use these tools, but there is an automated version of this that will go based on the modeling creation. It's a little bit more advanced though. So once we get this center marked, get our center lines in here. Our basic drawing setup is done there. You just have to put on the dimensions. And the good thing about the dimensioning tool is it's very easy to do. So let's go ahead though and also look at adding the scale in here. This is another trick you're going to need to know how to do. Is once I've left that menu that pops up at the beginning of the drawing menu where I type in all the text for my title block, how do I get back to it? And this is kind of tricky. So if you go over here, you're going to go to where it says IVTech Landscape A. That's our title block. You're going to drop that down with the plus sign, and there's a thing in there that says field text. If you double click that, it brings that box back up where you can edit it. A lot of people try to figure this out for good reason, and they right click this and they say, oh, well, edit definition, that's probably what I want, right? What this does is it actually takes you into the menu where you can edit the foundation that creates the text and the autofill and the questioning and the dimensions behind the title block. This is really more editing than you want. It's not where you want to go to change the text. So if you find yourself in here, you've gone too far. We'll talk about this in METC 220, and I'll show you guys how I made this title block and how you actually go through and create your own with fields and auto-populating text. But for now, that's too much for you. So just hit the Finish Sketch button. If you see that, get out of there. Or a Control-Z is always good. So when you want to edit the text in here, either do it at the beginning, or you can go in and find under Sheet 1 or Sheet whatever, IVTech Landscape, Field Text, and it brings you right back in here. So my orthographic views are at a 1:1 scale, so I'm just going to say 1:1 and hit OK. The scale for the isometric view doesn't really count, so we know it's half scale, but we're concerned the scale box relates to these guys. So what scale is the orthographic part of your drawing? So at this point, to finish this, what you would do is you would take your dimension tool and put the dimensions on there. And this is why we spent all of our time last week, or last session in 6, talking about how do you dimension a drawing, because a lot of people will go through all these steps and they did a really nice job. They modeled the part very well. They've put all the center marks and center lines on there. They've got all caps on their title block. The files are the right names. The files are in the right locations. Everything looks good. And then they get to the dimension tool and they ruin it. So this is where you want to think about those 5 rules we talked about last time for dimension placement. And how do you decide what's a good dimension or a bad dimension? So we went through and did these already. So if you want, you can revisit Module 6. I think I've got these in PowerPoint lecture. I've got the finished ones in here that you guys can look at. Yeah, so dimensioning practice number 1 finished. I think my PDFs are in inches. We actually did these in millimeters. So the numbers are different, but the placement is kind of what matters here. So if we wanted to dimension this, I could basically go through and grab my dimension tool now and say, well, give me this overall dimension right here. I'm going to drop that on the drawing. Give me the dimension of this line. Drop it on there. And you can see how it snaps into different locations to match up with those drawing standards. The text size is already fixed. The arrow size is fixed. The extension is fixed on your dimension lines. Now, one thing to be careful of, notice on mine, my visible gap is missing right here. This is kind of an expert thing that a lot of people don't pick up on. It's supposed to look like this. So why didn't it work? Well, it has to do with what lines you dimension to. So when I dimension to this, it's putting that visible gap at the bottom. So what I could try and do is dimension to the sides instead and have it put the visible gap in that way. So sometimes what you pick is going to determine whether or not the visible gap on the ends of your dimensions show up the way that they should. I can put my total in here. Notice that this is a metric drawing, so it's allowing us to put the text vertically like we talked about last time. And at this point, you're basically just going through clicking stuff. You can see this is bad. I shouldn't have done that. So I can take this text and drag it around. Like I could put it down here if I want to. So the actual dimensioning of the drawing is not that hard. It's very easy to mess up. The dimension tool is easy to use. The methodology of what dimensions do you put on there, what we spent the whole time last time talking about, that's the important part. Because it's almost too easy to put these dimensions on, right? So a couple other things. I'm just going to show you some other features that you can use in the drawing menu when you set up a drawing. They don't really apply to this part, but I want to show you what you can do with this IDW file just kind of to finish up here. Some different capabilities you have and what some of these other tools do, whether or not you need them for this particular part. So I may change this part just to make an example out of them here. So if we go back to our place views tab, let's go to annotate, sorry. On annotate, we can also put in leaders. So if I wanted to put a note in here, like if I right click and go to continue, I can use leader text to put in just notes. So I could tell the machinist, like, drill this hole last, for whatever reason. I can put just text notes in there for instructional purposes if I need to. I can also put my dimension on there, which, we wanted to use a multiplier on this when we did the drawing. So I could double click this dimension and edit it now. And these, or this grayed out set of symbols right here, like less than, greater than, this is what indicates your dimension text. So think of this as the diameter 17. This is the piece that's going to automatically fill itself in. So I can click after that or before it if I want to, and I can type in stuff. So I could say 2 times and hit space, and you can see it in there. And that's how you can edit your dimensions, okay? Unfortunately, this is a trick people use sometimes if they're not good at modeling. They will fudge the dimensions on the drawing, meaning that they'll come in here and sort of cheat and change them. That they'll turn it off, like they'll say hide dimension value, and this is really supposed to be 115. And they'll lie on the drawing about it, but if you measure it, it doesn't come out right, and it doesn't match with the 3D model. So That's a bad thing to do, but people do that sometimes if they can't figure out how to work the software. So don't do that ever, but it can be done. So that's the leader tool. Another really nice one is the hole and thread tool. If you use the hole tool in your model, this is one that's really handy. So if I go back to my part, I'm just going to make another hole with the hole tool, like maybe with a counter bore or some threads in it or something. So if I grab the hole tool, and let's maybe do one on the end here. Let's do a counterboard threaded hole. And yeah, let's go M8. So let's do an M8 hole. Let's make it a blind hole. So I don't want it to go all the way through the part. So instead of through all, let's go distance. And let's set up our sizes here. So let's say our counterbore is maybe 12. And let's make it a little bit deeper. Let's say it's 4 millimeters deep. There we go. So I'm going to put a blind counterboard tapped hole in this part, which will actually come through here. So let's hit OK. There we go. Let's delete this out, actually. I don't want to have that one in there. So I'm going to go back to my sketch and just delete this circle off. Hit Finish. Hit Accept. You can see my extrusion is mad now because one of my closed profiles disappeared. So it's mad over here. So I can just right-click and go to Edit Feature. Reselect that profile, hit OK, and it patches itself back up. So sometimes you have to go back and fix things. So there is my counterboard hole. So I can save this now, go back to my drawing, and with a little bit of thinking, it draws it in there. Now you can see some of my dimensions have turned pink. And what that means is Inventor is telling you a feature that used to exist in the part is gone now. And so the notes that are on your drawing don't mean anything. And it's basically telling you like, hey, this stuff's outdated. You probably should delete it. But Inventor doesn't want to take things off your drawing without asking you. So it's kind of like it's highlighting and it's saying, hey, something's wrong here because this stuff's gone now. So really all I'm going to do is just click on those and delete them. But it's Inventor's way of saying something's changed. So here I've got this complicated hole, right? It's counterbored to a specific depth. It's threaded. It's a blind hole. It's not fully threaded. It's threaded to about 2/3 of its length. So trying to use the leader text on this and build a hole note is tricky for people sometimes if they're new to mechanical drawings. Maybe they don't understand the terminology or how you note the threads inside of a hole and the different hole types. So this is where the hole and thread tool is very good. You can just click on this thing. And again, I wouldn't dimension it here because it's hidden. So let's go down here actually where it's visible. This is where you would want to dimension it. So I'm going to go to hole and thread, click the outside of that counterbore, and then try and find a spot where I can fit this thing up here. So there is your complete hole note with all the symbols in the right places and the right order all built out. So the M8 by 125, 16 deep, that is the actual threaded part of the hole right here. So that's the M8 16 deep from the surface. And then down here is my counterbore note. My 12 millimeters is this diameter, and the depth of 4 is this dimension. So just with one click, if you use the hole tool in your model, with one click in the drawing menu, you can put all the details for the hole on there, the threads, everything. You can't do that if you use the extrude tool. So if you're someone that fell in love with the extrude tool instead of the hole tool, you're going to pay the price when you get to the modeling or into the drawing creation because you don't have the capability of using this. So notice if I try and use this on here, it's probably not going to do much. Yeah, it figures out that it's a through hole. But if you get into more complicated things, it probably won't work. So let's try and counterbore this. But let's do it with an extrusion. There is a point where using the extrude tool will limit your capabilities. So I guess what I'm trying to say is use the hole tool if you can, because in the drawing menu, it makes your life a lot easier when you go to put the notes on the drawings for your drawing page. Let's save that, go back to the drawing. You can see Inventor's mad. It said, hey, something's wrong now. Things have moved around. They've really updated this. It actually works pretty well. So there is a point where you can break it, but it's pretty good now at figuring out what's going on with this hole. So I still prefer the hole tool because I think it does a better job of noting it and it's easier to make. So You can get away with some of it though with the extrude tool. They've added more and more into the software. So that's the whole tool. It's a nice one to know. You can do it just with threaded stuff too. So if I had, for instance, maybe like a threaded feature on this part that wasn't a hole. So let's make this 8 millimeters. And yes, I'm not constraining my sketches, so this is bad what I'm doing, but just for the speed of showing this to you. So let's thread this. I'm going to click on that. It's got an 8 millimeter thread on it. I can hit OK. So something that's threaded like that, I can also use this feature on. You can see it shows the thread right there. I can go to the hole and thread tool, click that thread, and it will list the thread on there. So it's an M8 by 125. I don't know if it'll do it on the side. Yep, it will. So I can drop that in then. So it's good for that too. So that's hole, thread, dimension, leader, your center marks and center lines. That will do most of what you need to for this class. You're not going to have to get into any of the weirder stuff like chamfer or punch or bend. I will show you baseline and chain dimensions because they're kind of nice for this part. So a part like this, these are some different tricks you can use for dimensioning this that make things a little bit quicker. So let me get rid of these dimensions. I'll show you a different way of dimensioning this thing. And let's actually go back here to our standard part. So we're going to do a bunch of undos. Hopefully it'll let me go back that far. Yep. Okay, there we go. Okay, so another way you could dimension this is something called baseline dimensions. These are the ones that a machinist will really appreciate you for. So if you have machinists where you work and you want to make friends with them, this is a good way to make some friends. The baseline tool will measure everything off of a corner point, and this would be the same way that like a CNC machine would be set up. Like a CNC milling machine would clamp a part into a fixture, like a vise. And I'll show you kind of an old school one here. Like if we look at an old school, like a manual mill. Here we go. Your CNC machine is going to have a readout that tells you where 000 on the part is, and then the machinist will actually move everything off of that, and they pick a corner on the piece typically to reference all of their dimensions off of. So as the designer, when you set up a drawing for somebody that's using a machine like that, if you can measure everything off of one point on your model, it makes it a lot easier for them to figure out the dimensions. So the way you would do that on a part like this is I would probably pick like the front left corner right here to be 0, like right there. And what I'm going to do is do baseline dimensions and measure all my features off of this front corner point right here. So if I go to baseline, it may take me a couple clicks to get this right. Select model or sketch geometry. I believe you put your biggest dimension in there first. Yeah, and you can go through and click stuff. Okay, so I wouldn't do that on this, but you know, you wouldn't dimension to the hole because it's hidden. But you can set this up, and then notice these baseline dimensions when you use this baseline tool. It's just a quicker way because you can go through and click stuff and it stacks all the dimensions automatically. But the machinist would like this because everything is dimensioned off of a common edge. And I could do the same thing like up here. I could grab my baseline tool, say I'm going to base all my measurements off of that. Here's my total. And I can go through and click intermittent points in my model, and it will build those in. And you can see it stacks the shorter ones closer and the longer ones farther away. And you know, they need some adjusting typically too. But that's baseline measuring. You measure everything back from a common point. Machinists love it. Designers don't love it quite as much because you can see it takes up a lot of page space. The other option to that is what's called continuous or chain dimensions. Chain dimensions right here are where you measure from one thing to the next. So for instance, like up here, I would say, well, let me measure to there, and then to here, and then to here, and then to here. And right click and go to continue. And it's just kind of a shortcut. Machinists don't like these as much because they have to get out their calculator and add up a bunch of numbers to try and figure out where the next hole should go. Designers like it because you can see it saves a lot of page space. So those are kind of two different dimensioning mindsets, either baseline or chain. Another good one you can do is ordinate dimensions. These are another ones that machinists like. It's kind of similar to baseline dimensions. I like ordinate dimensions a lot because you can just measure to coordinate points instead. So I can say, like, this is the beginning of my measurement system down here. That's the origin. And I can go through and just click things and drop their locations onto my model. I could go the other way. Measure off this face, for instance. Oops. If I can get it right here. There we go. So you can drop coordinate points in there, and it basically tells them here is the XY location of this crossing point. Okay, so it's another way of listing dimensions out. Machinists like these a lot for very complicated parts. It's a very efficient way of putting a ton of dimensions on a part. So if you have something like this that's got holes and cutouts all over it, ordinate dimensions are a really good way to do that. It keeps your drawing from getting super, super cluttered. So it's just another tool you have that you can use if you need to. Okay. So let's get out of this annotate menu now and look at some other, like, some drawing view tricks. This is kind of where the fun stuff is. I think we've talked about noting things on the drawing enough. You guys know how to do holes and dimensions and center marks and center lines and stuff like that. It's not going to let me get rid of this now. There we go. Okay. So here's some other cool stuff you can do, some different view types. So obviously you can use the projected button to project other views in here. Like if you decide you need a view that you left off, you can always project off of your other views to add additional views. So with just a few clicks, you can make any different orientation or view of your part that you want to. You can also do some fancier stuff, like you can do section views if you need to, or detail views. So let's do a section view. Let's say I want to take this part and cut down through it and show what it would look like if I cut through it at that location. So maybe instead I want to do, how do we want to do this? Let's do a section through this top section, maybe up here. So let's take off that isometric view for a second. And just for fun, let's cut a section. So I'm going to click the section button, and then down here it says select a view or sketch. So basically, what do you want to cut through? So let's cut through this. Now I'm going to draw a line through it and say cut from here to here. Right click and go to continue. And now I can take that and drop it anywhere on my drawing. And normally you'd want a bigger piece of paper also, but I could do this as a section view if I wanted, and you can see I can actually cut through that. The really fun thing is you can take section views and then project them. So I could take this and project it as an isometric view. And you can do isometric sections with just a few clicks that would take somebody forever to draw in AutoCAD or another CAD software. So if you want to show someone, hey, here's what this thing looks like sliced in half, and you want to show it in a 3D orientation, you can do that with projecting a section view. You can also do breakouts. So let me go back and take some of these off. Maybe we could do a breakout where we can take one of the walls off of an object to show the inside of it. So let's do a breakout here, maybe on this view. Oh, we have to have a sketch first. So let's go and do a sketch. We're going to start a sketch on this face. And this is one where you probably want to use like a spline. So I want to cut out a breakout around this hole. We're just going to cut the front of it off. Come on, Inventor. And we'll just cheat and run a line across the top of it here. Okay, so we have a closed profile. Now let's go back to breakout. We choose our depth. So let's say, how far do we want to go through this? Back to that hole, maybe. How deep is the part? Let's just go halfway. An inch, maybe. So let's say, let's go 25 millimeters. From here. Oh, didn't go far enough. Let's see if it'll let me project it here. This is basically what it does, though, is it creates a... Oh, I went too far. I cut all the way through it. It makes a breakout where you can see to the inside of a part. So this is something you'd use like on... Maybe like you want to break off the side of an engine so you can see inside of it and see all the parts that are in there. You can do breakouts for that also. So breakout views are kind of neat. And these are all just tricks to try and fit stuff onto drawing pages and show more detail. Overlays are good if you want to show like the multiple positions of something. So for instance, on here they have this wheel on this suspension that can move up and down. So they're showing like the upper and lower travel on these suspension arms. Detail views are the last one I'll show you. And I think at that point we've probably hit enough. I don't want to overload your brain here. Detail views are good if you want to show something that's very small, but you want to show it at a bigger scale. So let's say in this part I have maybe a tiny little hole right here on the top of this. Let's say it's like a 3 millimeter hole up on the top of this part. And let's take the counter bore off. All right, so I got this little tiny 3 millimeter hole. And I want to show it at a bigger scale. So what I could do is say, well, let's do a detail view. On this. So I'm going to pick the view. Then you click and drag where you want the detail view to go. And then drop it on the drawing. And you can choose what scale you want. So I can make it twice as big, or 3 times as big, or 4 times as big. So I could blow it up 4 times bigger. Maybe let's shrink this down a little bit. And now you can see that at a bigger scale where I can dimension to it if I need to. So these are all just tricks to try and help people visualize things the best way possible and fit them on the drawing page. Okay. Now sometimes you'll see I'm starting to run out of drawing page space, so you can go to a bigger size sheet if you need to. So this is set up for an A size, but if you want, you can go to sheet 1 and go to edit sheet. And I can always go to a bigger size like A, B, C, or D. I wouldn't go past a D size, but you know, if I need more room, I could go to a B size, for instance, and do an 11 by 17. So now I got a lot more room to fit this on my drawing page. So most of what we will do is set up for an A size sheet, but you can go up to a bigger page size if you need to. Okay, I think I'm trying to make sure if I've told you guys everything you need to know here. We talked about file management. We talked about isometric drawing setup, center lines, center marks, dimensioning, section views. Oh, the last thing I forgot to show you is how to export this. Let's say you've made this beautiful drawing, which this looks pretty bad. Let me rewind here a little bit to where I actually had something useful. Okay, so let's say this is my drawing. Assume that I went through and put all the dimensions on here and I had it completely finished. I want to share this with somebody now. So you don't usually want to send them your IDW file because they probably don't have Inventor software, so they can't open it up. And you also may not want to give them the ability to change the design. So if you send somebody your IDW file, now they have the ability to edit it and they could change what you designed without really you knowing it. So usually you want to send a PDF, so it's just a snapshot of your design and they don't have the ability to change it. So you can go to File, Export, PDF, and you're just going to choose where you want to save this thing. I usually keep the name the same. There are some options here if you want to. If you have a multiple page drawing, like you have 6 or 8 pages in your drawing file, it will only PDF the first page unless you come into this options menu and set it to all sheets. Watch out for that. You can also change the resolution if you want higher or lower resolution. So I just have 1 page, so I'm going to go current sheet. But if I had like 10 pages, I'd have to come into options and pick all sheets. So I can save this now. It will really quickly PDF it. And I think it will even open it up usually when it's done. No, maybe not. We can open it. That's fine. There we go. Ta-da. There's our finished drawing. So you can make some really nice looking drawings with just a few clicks, and you can take this and email it to somebody else if you need to. And this is kind of the paperless thing. I think most people are going to this, at least, where we still put things in paper format, but we don't necessarily waste the time and money of printing them out. So you can still format them for a standard paper size if you need to, and you can take that and save it. There are ways to do 3D PDFs also, which is kind of neat. Where are they at? Unless they took it out of this. No. I think you have to do it as your part file, actually. You can do a 3D PDF where you can send this to somebody and they can actually rotate it around. Let's see if this will actually work. I've had mixed results with this in the past, so this may fall flat, I'll tell you now. Let's try it and see what we get. So we'll actually take your part file, and this would be more for visualization. Like if you have someone that just wants to see what your design looks like, you can take your design and turn it into a 3D PDF and send it to them this way. And that way they can look at it and rotate it around still, but it's not in a standard like drawing page format necessarily. So this is kind of new. This is lesser known. It doesn't get used as much, but it's just kind of a neat extra option. I would not look at this as a way of excellent communication. It's more just kind of an add-on tool that's kind of nice to have. So we're almost done here. That's what I was afraid of. I've had this happen before. The way this is supposed to work is it shows you like 3D views of these things, and you can rotate them around in the PDF. So we talk about this again in METC 220, so it's not a huge deal, but that option is in there. There are YouTube videos about it too if you want to look around and learn more about it. But you guys should know how to make a regular 2D PDF now, which is nice. Okay, so I'm going to cut this video right here. I think you guys know everything you need to know now about setting up some standard drawing pages with typical orthographic setup on them. I am going to make a video to walk you through the homework assignment for this week. So for this session 7, what we're going to do is we're going to go through and practice setting up some other drawing pages together. So these are of models that we've done already. So you should have these things modeled already. So we're just going to bring them in and then set up the drawing pages together. There also is a short quiz, online assessment number 4. So make sure you do that. It's 10 points, quick and easy. That's the other part of your session 7 homework assignment. So again, remember the midterm exam's coming up. I'll remind you of that in session 8 with another short video. We're going to do these 3 drawing files together in my next video for the homework. And then you also want to make sure on your own you go in and do online assessment number 4. So that's it for this video. Hopefully you've learned a little bit about setting up IDW pages in Inventor, and you feel like you can take your designs and start to communicate them to other people. So I'll see you guys in the next video. Have a good one. Bye.